Now we have to go for a next numerical based on Routh stability criteria, but it is a type of difficulty number 1. So in starting we will solve as a normal procedure. Okay, the solution standard characteristic equation is a0 s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 till the an equal to 0. Okay, this is the equation number 1. This is equation number 2. Compare equation number 1 and 2. Write down the coefficients of characteristic equation a0, a1, a2, a3, a4, a5. a0 1, a1 2, a2 3, a3 6, a4 2, a5 is 1. The next step is step number 2, Routh's array. It will start from the s to the power n, and here n is 5. So s to the power 5. Okay, so s to the power 4. So the first row is of even coefficients. So even coefficients are 1, 3. I am writing directly 1, 2, 3, 6, 2, 1. Now s to the power q. Okay, solve this. 2 into 3 minus 6 into 1 upon 2. That is 2 into 3. 1 second. 2 into 3 minus 6 into 1 upon 6 upon 2. Answer 0. It is 0. Next, 2 into 2 minus 1 into 1, it is 1 upon the 2. How much? 1.5. Okay, now see, here we get the equation is that where we have the first term, the first column, first term is 0, and the rest of values, we can say that we have the rest of values in coefficients value, some valuable values है, ठीक है. So if we solve the next term, okay, this is a difficulty number 1, that the first column term is 0 and the remaining columns values are valuable, some coefficients values are there. If we go for the s to the power 2, what happened? We will multiply it with 0 by 0 into 6 minus 1.5 into 2 upon the 0. Whenever we multiply it by 0, it will comes as the term as the term, so it will as an comes as an infinity. Okay, and we will go for the next part. Always it will be infinity or 0, infinity or 0. We cannot conclude the stability, we cannot comment on the stability of the system. Okay, so this is the difficulty number 1. So for this case, what we have to do, we have to do the remedy of this is that we have to replace this 0, this 0 by epsilon. Okay, we have to apply this as an epsilon. Okay, now we have to go with the epsilon term. Okay, this is epsilon, this is 1.5, this is 0. Now cross multiply epsilon into 6, it is 6 epsilon minus 1.5 into 2 upon epsilon. Okay, all the terms are come now as an epsilon. Next term, epsilon into 1 is 1 epsilon minus 0 into 2 0 upon the epsilon, so it will be 1. Okay, here it is this is s to the power 2 row. Next part, s to the power 1. Okay, so it will be now this term into 1.5 and 1 into epsilon. Okay, so 6 epsilon minus 1.5 upon epsilon into 1.5, sorry, epsilon into 1.5 minus epsilon upon 6 epsilon minus 1.5 into 2 upon epsilon. Okay, this is your first term, and for the second term it is comes as an 0, so it is a 0 like the similar one. Next, go for the s to the power 0, s to the power 0. Now what we have to multiply? We have to multiply this term with this 1 upon this. So the answer is, so the here the value of s to the power 0 is this into this minus 0 into this is 1. Okay, the next part is we have to solve these terms, the epsilon terms, this and this, using the epsilon as a 0 limit. Minus 1.5 into 2 upon epsilon. Now put limit as an epsilon 0, so we will get, so it will as an divided by 0 is infinity. Next, limit epsilon tends to 0, epsilon tends to 0. Equation is 6 epsilon minus 1.5 into 2 upon epsilon into 1.5 minus epsilon. Okay, now we have to solve this. So first, don't put directly a limit. Now first cross multiply and simplify. Okay, so it will be limit epsilon tends to 0. Okay, 6 epsilon minus 3 epsilon minus epsilon. Now see, simply cross multiply it is, so 6 epsilon minus 3 in bracket 1.5 minus epsilon square upon epsilon upon 6 epsilon minus 3 upon epsilon. So this epsilon get cancelled, so the remaining term is 6 epsilon, now open the bracket, into 1.5 minus 3 into 1.5 upon 6 epsilon minus 3. Okay, so when we put the epsilon equal to 0, the final term is, see here, the epsilon into 0 put करेंगे तो this term as in 0 and this term is also 0. So the final one is that minus 3 into 1.5 upon the minus 3. So the answer is your 1.5. Clear? So after putting the values, जो values हमने निकाले थे 6 epsilon minus 3, sorry, 6 epsilon minus 1.5 into 2 upon epsilon. All this, after putting the limits, we have to write down the values here. And now you have to check the stability condition. The condition is that there should not be any sign change in the first column of Routh's array. Is there any sign change? Since there is no sign change in first column of Routh's array, so the system is stable. Write down all these sentences.